If you are trying to reduce waste at your facility or lessen your facility's environmental impact, there are three main methods you can use to accomplish this. You can either change the material, change the process, or change the technology. This video focuses specifically on the second method, changing the process, and how you can use this method to reduce or eliminate hazardous chemicals. In this video, we are going to look at a number of examples from different industries and how they change their process to reduce hazardous materials. Although these examples are tied to specific industries, we would encourage you to watch the entire video, as the examples might give you a similar idea for a waste reduction project at your facility. Examples in this video include the following: two from the painting and coating industry, one about training and another about standardizing operations, an example from the printing industry where a facility moved to a heat press system, and finally an example about chemical neutralization at a water treatment facility. Alright, let's take a look at our first example. Many companies with painting and coating operations have already begun using high-volume, low-pressure, or HVLP paint guns. This change improves paint transfer efficiency, so more of the coatings end up on the product. However, not all companies train their staff on how to properly use the HVLP paint guns. Let's take a look at how this can translate into savings. In this example, a facility uses 420 gallons per year of coatings to spray approximately 15 cars per week using a conventional spray gun. A conventional spray gun has a typical transfer efficiency of 40%. The company decides to switch to HVLP spray guns, which increases the transfer efficiency from 40 to 49%. First, we'll move our assumptions to the bottom of the screen. As we work through these calculations, feel free to pause the video as needed to make sure you understand them. You may even want to get out a pen and paper and run through the numbers yourself. If we multiply 420 gallons used per year by the 40% transfer efficiency, we see that only 168 of the 420 gallons is actually transferred and ends up on the cars. Assuming then that 168 gallons is what is needed to paint the cars, we next want to determine how many gallons we would need if we used the HVLP paint gun. We'll use the same equation, except now our transfer efficiency is 49%, and we know how much paint transfers to the cars, 168 gallons. If we divide both sides by 49%, or 0.49, we find that only 343 gallons are needed with an HVLP paint gun. That's a savings of 77 gallons per year. At a cost of $90 per gallon, this represents an annual cost savings of $6,930. Now, changing out the type of paint guns was an example of how we can change the technology. The facility decides to take this project a step further and change the process by training its workers on how to properly use the new HVLP spray guns, which further improves the transfer efficiency to 61%. We'll add that to our list of assumptions. Using the same method and equations just shown with the conventional and HVLP spray guns, we find the facility now only needs 275 gallons per year. This ends up being a total savings compared to the conventional gun of 145 gallons of coatings and $13,050 per year. This is a great example of how a facility can do more than just one of the waste reduction methods we discussed earlier. Here, we combine changing the technology with changing the process to achieve significant savings. This example also shows how businesses can continue to make step-by-step improvements to their operations. Here's another example from the painting and coating industry. This facility had a pollution prevention intern assist with identifying opportunities for waste reduction. This intern began researching the company's painting operation, which is used to paint approximately 200 modular buildings per year. Each building requires 2 to 3 coatings, which includes a primer, intermediate, and final cover. Each time the paint lines were cleaned out for a color or primer change, approximately 1 gallon of coating was lost, while 3 to 4 gallons of solvent were required to clean the paint lines and guns. This cleaning process was occurring 3 to 4 times per day, 5 days per week. By standardizing the process and using primarily the same type of primer for each job, rather than giving clients the option, the intern found it was possible to save 1 gallon of paint and 3 to 4 gallons of solvent per building. This process change resulted in an annual reduction of 200 gallons of carbozinc paint and approximately 600 gallons of methyl ethyl ketone solvent. At a cost of $98 per gallon for the primer, up to $19,600 in annual savings can be realized in primer purchasing costs and $3,800 in solvent costs. It's important to note this does not include additional labor and operational savings from reducing the number of line changes. A printing company was able to reduce its waste and solvent use by changing the process. Rather than use traditional, non-recyclable film materials, the facility now operates fully on heat press systems that use 100% recyclable aluminum plates. In addition to the waste reduction associated with this process change, material costs have also been reduced. The purchase of film material had cost the facility approximately $90,000 per year. Since moving to the heat press systems, silver waste has been completely removed from the facility, and the new printing technologies have significantly reduced solvent use. This has had a positive impact on the company's purchasing cost and has also reduced the amount of hazardous waste requiring disposal. Our final example is from a wastewater treatment plant that hired a pollution prevention intern to research opportunities for chemical reduction. The intern examined the facility's waste neutralization process, in which 2 types of waste were previously treated separately, as shown in the flowchart here. The intern determined the wastewater treatment facility could change the process by incorporating self-neutralization. The 2 waste streams are now combined to partially treat each other before raw neutralization chemicals are added. For a facility producing 270,000 gallons of treated wastewater per day, the resulting annual savings were 34,000 pounds of sodium bisulfite, 26,000 pounds of sodium hydroxide solution, and 80,000 pounds of bleach, which adds up to $12,000 per year. The cost for programming this automated self-neutralization process was projected to cost $2,200 and not increase the length of treatment time. Additional process changes identified by the intern include recalibrating pumps to prevent excess chemical additions due to pumps running faster than intended, and checking pipe orifices to ensure there are no blockages. As you can see from the examples provided, the opportunities to change the process are unlimited. Changing the process can reduce pollution, save your facility money, and improve the work environment. Many times, it just takes looking at an existing process with a fresh set of eyes in order to get a new perspective. Make sure to involve staff across your facility and ask for their ideas. Many ideas come from unexpected places. And don't forget to track your material use and waste generation. This can be incredibly helpful in determining if and how much you are saving with the new process. To learn more about this topic, or to find out about the other methods listed here, which were changing the technology and changing the material, you can visit the K-State Pollution Prevention Institute's website at www.ksuppi.org. If you are interested in hiring a pollution prevention intern, check EPA's P2 internships website at the link shown on the screen to see if your state has an internship program. In Kansas, you can visit www.sbeep.org/p2/intern-program to learn more. If you have any questions, you can contact the Pollution Prevention Institute at Kansas State University using the contact information shown on this screen.